CERN discovers hints of mysterious new particle. This is extremely interesting. It comes from a headline. The New York Times says physicists in Europe find tantalizing hints of a mysterious new particle. It starts with the question, does the Higgs boson have a cousin? Two teams of physicists working independently at the Large Hadron Collider at CERN reported on Tuesday that they have seen traces of what could be a new fundamental particle of nature. One possibility out of a gaggle of wild and not so wild ideas springing to life as the day went on is that the particle, assuming it's real, is a heavier version of the Higgs boson, a particle that explains why other particles have mass. And that would be interesting because if that's true, that might give evidence towards the theory of supersymmetry, which predicts there should be 5 Higgs bosons. And supersymmetry, if true, could go into explaining what dark matter is, and basically there would be a lot more particles. The standard model would only be half or even less than half of what is actually in existence. So that would be really interesting. Another possibility is that it is a graviton, the supposed quantum carrier of gravity, whose discovery could imply the existence of extra dimensions of space-time. Now, that's another thing that's really interesting. Due to quantum field theory, physicists know that gravitons exist, or at least there's good reason to believe that, because for every quantum field it has an associated particle. So the Higgs field has the Higgs boson, the electromagnetic field has photons, and the gravitational field should have gravitons. So if that's discovered, and I've done videos and blogs and stuff, you can go to ministudyministry.com, on how impactful a graviton discovery would be. I mean, they've been talking for years now about possibly using gravitons to communicate with extra dimensions, and that sounds made up, but it's not. Brian Greene hosted a documentary, narrated a documentary, and part of that documentary he talked about it, and you can find information on that in my blog, joshpeckdisclosure.blogspot.com, and all the information's at ministudyministry.com. But basically, gravitons can travel between dimensions. They have the natural ability to escape into higher dimensions, which might explain why gravity is so weak compared to the other forces. So if that's true, that's also something that could explain what dark matter is. If there's extra dimensional matter out there and gravity is escaping to it, that extra dimensional matter could actually be dark matter. So if they discover gravitons, that would be huge. It goes on to say, at the end of a long chain of ifs could be a revolution, the first clues to a theory of nature that goes beyond the so-called standard model, which has ruled physics for the last quarter century. It is, however, far too soon to shout "whale ahoy," physicists both inside and outside CERN said, noting that the history of particle physics is rife with statistical flukes and anomalies that disappeared when more data was compiled. A coincidence is the most popular explanation for the surprising bumps in data from the collider, physicists from the experiments cautioned, saying that a lot more data was needed and would in fact be soon available. "I don't think there is anyone around who thinks this is conclusive," said Kyle Cranmer, a physicist from New York University who works on one of the CERN teams known as ATLAS. "But it would be huge if true," he said, noting that many theorists had put their other work aside to study the new result. "When all the statistical effects are taken into consideration," Dr. Cranmer said, "the bump in the ATLAS data had about a 1 in 93 chance of being a fluke, which is far stronger than the 1 in 3.5 million odds of mere chance, known as 5 sigma, considered to be the gold standard for discovery." And this is something that I talk about in my new book, and hopefully it'll be out soon. Keep checking ministudyministry.com for information on that. But I go into what this whole sigma thing is, and basically Everything at CERN, when a new discovery is made, it's done by statistics. Uh, they can't just view for example, the Higgs boson, it decays so fast into other particles that they don't actually see the Higgs boson. They see what other particles are created from a collision. So they look at those, and when you compile enough of them, you can get enough statistical data that says this most likely is a Higgs boson. Once that piles up enough, this says 1 in 3.5 million odds, which is called, like it says 5 sigma. Then they can consider it a discovery of a new particle. So 1 in 93 chance. I mean, it seems like that's rare. It seems like that's a big chance, but really in physics it's not. I mean, it's substantial enough to raise some eyebrows, but they'll have to collect more data to really know for sure. So it says in here that might not be enough to bother presenting in a talk, except for the fact that the competing CERN team, named CMS, found a bump in the same place, and that's part of the reason why they have 2 detectors. Well, actually, they have 7, but for these types of things, they have CMS and Atlas. So if it's just a fluke, chances are both of them aren't going to pick it up. Just one or the other would. Now, just because both of them picked up this fluke, that still doesn't mean it's definitely a new particle, but it's stronger evidence saying that it could be. So there's a quote here that says, "What is nice is that it is not a particularly crazy signal in a quite clean channel," said Nima Arkani Hamed, a particle theorist at the Institute for Advanced Study in Princeton, New Jersey, speaking before the announcement. "So, while we are nowhere near moving champagne even vaguely close to the fridge, it is intriguing. Physicists could not help wondering if history was about to repeat itself. It was 4 years ago this week that the same 2 teams' detection of matching bumps in Large Hadron Collider data set the clock ticking for the discovery of the Higgs boson 6 months later. And so the auditorium at CERN outside Geneva was so packed on Tuesday that some officials had to sit on the floor for a 2-hour presentation about the center's recent work that began with the entire crowd singing happy birthday to Claire Lee, one of the experimenters from Brookhaven National Laboratory on Long Island. At one point, Rolf Heuer, the departing Director General of CERN, tried to get people to move off the steps, declaring that they were in a fire hazard. When they did not move, he joked that he now knew he was a lame duck. When physicists announced in 2012 that they had indeed discovered the Higgs boson, it was not the end of physics. It was not even, to paraphrase Winston Churchill, the beginning of the end. It might, they hoped, be the end of the beginning. The Higgs boson was the last missing piece of the Standard Model, which explains all we know about subatomic particles and forces. But there are questions this model does not answer, such as what happens at the bottom of a black hole, the identity of dark matter and dark energy that rule the cosmos, or why the universe is matter and not antimatter. The Large Hadron Collider was built at a cost of some $10 billion to speed protons around an 18-mile underground track at more than 99% the speed of light and smash them together in search of new particles and forces of nature. By virtue of Einstein's equivalence of mass and energy, the more energy poured into these collisions, the more massive particles can come out of them. And by the logic of quantum microscopy, the more energy they have to spend, the smaller and more intimate details of nature physicists can see. Parked along the underground racetrack are a pair of mammoth 6-story conglomerates of computers, crystals, wires, and magnets, Atlas and CMS, each operated by 3,000 physicists who aim to catch and classify everything that comes out of those microscopic samples of primordial fire. During its first 2 years of running, the collider fired protons the building blocks of ordinary matter, to energies of about 4 trillion electron volts in the interchangeable units of mass and energy that physicists prefer. By way of comparison, the naked proton weighs in at about 1 billion electron volts, and the Higgs boson is about 125 billion electron volts. Since June, after a 2-year shutdown, physicists at CERN have been running their collider at nearly twice the energy with which they had discovered the Higgs, firing twin beams of protons with 6.5 trillion electron volts of energy at each other in search of new particles to help point them to deeper laws. The main news since then has been mainly that there is no news yet, only tantalizing hints, bumps in the data that might be new particles and signposts of new theories or statistical demons. The most intriguing result so far, reported on Tuesday, is an excess of pairs of gamma rays corresponding to an energy of about 750 billion electron volts. The gamma rays, the physicist said, could be produced by the radioactive decay of a new particle, in this case, perhaps a cousin of the Higgs boson, which itself was first noticed because it decayed into an abundance of gamma rays. Or it could be a more massive particle that has decayed in steps down to a pair of photons. Nobody knows. No model predicted this, which is how some scientists like it. The more non-standard, the better, said Joe Licken, the director of research at the Fermi National Accelerator Laboratory and a member of one of the CERN teams. It will give people a lot to think about. We get paid to speculate. And Joe Licken's actually a pretty brilliant guy. He's got this presentation on YouTube that you should check out about the Higgs field or Higgs boson doomsday. I also wrote a blog article about that, and I do break that down in my new book because I actually think there might be some prophetic significance there, but it's absolutely fascinating, his research into that area. Marius Spiropoulo, I probably butchered that, a professor at Caltech and member of one of the detector teams, said, as experimentalists, we see a 750 billion electron volt beast decaying to 2 photons. Explaining it, she added, it's up to the theorists. The new results are based on the analysis of some 400 trillion proton-proton collisions. If the particle is real, Dr. Licken said, physicists should know by this summer when they will have 10 times as much data to present to scientists from all around the world who will convene in Chicago, Fermilab's backyard. Such a discovery would augur a fruitful future for cosmological wanderings and for the CERN Collider, which will be running for the next 20 years. It could also elevate proposals now on drawing boards in China and elsewhere to build even larger, more powerful colliders. We are barely coming to terms with the power and the glory of the CERN Collider's ability to operate at 13 trillion electron volts, Dr. Spiropoulos said in a text message. We are now entering the era of taking a shot in the dark. All right, so really interesting stuff. I'm curious to know what you guys think. What could this mean if a new particle is discovered? I mean, I guess it would depend on the particle, but in the extreme case that it's a graviton, that would be huge. That could actually be a bigger discovery than the Higgs boson back in 2012. But I mean, even if it is a heavier version of the Higgs boson, that could be evidenced for supersymmetry, which would still be a huge discovery. Or maybe it's all just statistical anomaly. So what do you think? What does this mean for our future? You know, what kind of world are we headed towards? I'd love to know what you think. Leave a comment. If you haven't done so already, subscribe to my channel. Share, rate, comment, subscribe, all that fun stuff. As always, thank you for watching. Take care and God bless.